When we talk about classical probability or theoretical probability, we're kind of assuming, like I said, that things occur as they should. That if I was to take my coin here and flip it, I should expect that about half the time I get heads and about half the time I get tails. But the problem is, I could flip the coin and get tails again, and flip the coin and get tails again, and flip the coin and get tails again, and keep flipping the coin and just keep getting tails over and over and over. Not necessarily forever, but maybe many times in a row. The point is that when we're talking about classical probability, we're assuming that life is going to be a bit cleaner and more patterned than it actually is. That things like coin flips will happen the way they do, and that I will eventually land ahead. That if we're talking about breaking things down by demographics, that will show in how the data set behaves. That everything's going to go in the exact pattern we would expect based on the numbers. But that's actually not guaranteed. You could even argue it's not particularly likely. And as a contrast to that classical approach, we have the empirical approach, where for empirical probability, the likelihood of an event is determined by the frequency with which it occurs. So you want the probability of event E, you just take the frequency of that event, the number of times that it happens, and divide by the total frequency overall. So to bring this back to language from chapter 2, you can think of empirical probability as being the relative frequency. It's actually the same measurement, just in a different frame of reference, where this tells us not how something should happen, but more realistically, how it does happen. To understand this, we're going to look at some examples. Where for our first example, we have that a company is conducting a phone survey of randomly selected individuals to determine the ages of social networking site users. So far, 975 have been surveyed, with the distribution given to show the results, where we want to find the probability that the next user surveyed is 18 to 35. So, we've got this data here, and if we want to find the probability in question, we want to find the probability of 18 to 35. All we have to do is just take the number of ways that we get 18 to 35 given that data set, which here is 468 divided by the total frequency of 975, and this is actually more or less fine as an answer, but if we want to get a decimal instead, we could say that this is about 0.48. So when we're talking about empirical probabilities, we're talking about where the numbers come from when a news report says 50% of this is that, or studies show that 2/3 of thing happen. But it's important to bear in mind that when we're talking about these things, just because we call them empirical doesn't necessarily mean that they are perfect or true representations of the situation. This is based on collected data, and when it comes to collected data, there's always an amount of room for sampling error, for bias, for impropriety that doesn't necessarily happen when you're just looking at the raw numbers. That is, when you're looking at the raw numbers in terms of classical probability by comparison. So for example, here, we might have that this is a decently drawn survey and this is a decently representative result. But here, we could also wonder about where those numbers came from. It is, after all, a phone survey. Did they text people at random? I generally don't respond to texts from unknown numbers. Did they call? I definitely wouldn't respond to a phone call from an unknown number, because I would assume that they are trying to scam me out of my car warranty information. So it's certainly possible that they didn't get a very good group if it was by phone, and even if it was, and if they did get someone good, how do you know that their questions were actually useful? They may have asked, do you use social networking such as MySpace or Facebook, which are generally at this point getting closer and closer to being outdated social networking sites? Or did they ask, do you use social networking at all? Or maybe they specified ones that are more modern, like TikTok and Snapchat, that you might not have as much knowledge of from older generations. The point being here that there's always room for empirical data to maybe not perfectly represent the situation, for exactly the same reason that there's always room for a sample to not properly represent a population. But anyway, before we move on from this, we've got one more example to look at that I'll say is a little bit heavier than what I normally cover here, but I think it is important stuff to discuss.